Hello, welcome back. This is Calculus by Dr. Oz. Today we're gonna go through an exercise where we're gonna using the benefits of having the p-series test for the given infinite series. And if we know that a given series is a p-series, we can use the result right here saying that the infinite series 1 over n to the p is convergent whenever p is strictly greater than 1, and it diverges for p's in between 0 and 1. And you can include p equals 1 into the divergent case because p equals 1 is a very special type of p-series. It's called harmonic series. So it's infinite series 1 over n, that's also convergent. So if you can pinpoint that the given series is a p-series, which is written in the form of 1 over n to the p, then all you're going to check for convergency is the number p. So if it's greater than 1, it's convergent. If it's less than 1, it's divergent. All right, so we have two simple examples here. This video is not going to be long, so why don't we go ahead and then get started. All right, so let's check the given infinite series. So I have 1 over n to the power of 1.03. And here we're talking about a p-series because it fits in this form here, right? For p equals 1.03, which is a number greater than 1, I can go ahead and then say that, in fact, conclude that this series is convergent. Okay, just a very simple conclusion here. In fact, the proof of this result here is relying on to the integral test, but we are sort of like completely bypassing the integral test to be applied for this series or for this series. We are just using this result to prove convergence or divergency. And the deal is the same in part B, and we still have a p-series for p equals pi, and pi is a number approximately equal to 314, which is greater than 1, strictly greater than 1, and we can go ahead and conclude the same for this infinite series, okay, as convergence. Okay, we can apply the same strategy for other p-series. Again, all you're going to look at is what p is. Is it bigger than 1 or smaller than 1? By the way, if p is a negative number, you can't really apply this test. So because we want p to be positive to start with. Okay. All right, I promised you that this was going to be a short video, and now we're ending this video. Thanks for watching. I'll see you in another video. Bye.